Yeah, the main goal for searching and a lot of search techniques, there is a lot of different techniques because you have different data sets or different type of data sets. And the main problem is there is no any single solution for searching. You have same function, but basically you have different techniques because it's not possible to make a universal algorithm for each problem to solve. And yeah, that's why algorithms in data structured course exists, because you need to understand in which situation or in which case you must pick different search. And when we're talking about algorithms and other functions from algorithms like sorting and maybe deleting, finding by some index and so on, we should think not with small data sets. With small data sets, you can't say that which complexity is for your algorithm. And best way to determine, you should use large data sets or like finite data sets like n, number n elements, and with n elements, if it works great without delays, then you're able to implement in your solution. And we have first most common pattern or algorithm, which is really easy to implement and easy to understand how it works searching at all. Because basic logic is, if you're using loops or if you're thinking in sequential manner with iteration or iterative solution, not recursively, so you have problem to solve if you pass some input like to find 20, like value at 20, or letter, some A, B, C or so. So you are thinking straightforward. And why it's not the best solution to find some info? Because you must search from start to end. And when you moving from start to end, basically, if you if you are lucky, you will find that info really fast. But it really depends. But the worst case will be the last element, like if we are looking at 20, maybe it will stay, or you'll find here at the last iteration. And if you sort that array, you take other step to sort, but sorted set will help a bit when you're searching. Because if you give some small numbers, then you will always reduce time for searching. But you're wasting time for sorting. And it really depends on those searching types. In common pattern, you're working with not search data sets. If we're talking about linear search, because we don't need to waste time to sort and then to find. The easiest and naive solution, just iterate through the whole collection and find that element. How to implement programmatically? Basic pseudocode for any language. Linear search, you're passing list, you're passing a key to find it, element, and you're iterating through the whole list. And if you match the item value, you return that location or index if you're working with array, or you must return index. So if we would like to implement that, later I created a new project and I will create CMake project and add a single solution instead Visual Studio, because if using Linux, Mac or so, I will give a cross-platform solution project. For that reason, I'm switched from Visual Studio now to CLion. And I will create a lot of CMake list TXTs and separate projects for each solution. For today, I will create searching. For next lecture, maybe I will create separate folder for each topic, different solution project or project. And to implement that search, what we will need? We need, of course, to print some. In some cases, I just use basic steps. And the main goal to create some function which is return founded item index. Basically, why it's not the best solution sometimes to return the current item from array? Because on searching you need only index, because in most cases you're working with array or list, and you only need a position of founded items, and later on you're able to extract and do some with that info. And basically when we looked here, we need to implement some end. If we're looking in integer array, later we're able to implement different, but I use integer is the easiest way to understand how it works with numbers. Later on you're able to use it instead of numbers objects, and it will be the same. And search, or we're able to call it linear search. And we passing, of course, if you would like more dynamic memory or use addresses, you're able to use pointers, smart pointers, or normal arrays like list or array. Doesn't matter, name is not the case. We creating array, we creating size, and also we creating key to find key. Why we need that n? Basically able to skip that step, because when we working with vector instead of array, it will be easier to get the size of array. Because when you're working with arrays and you don't know which size you giving here, like are you giving 5 or which size, or any size of array, you should give array size later. With vector you just reduce to single parameter instead here, and key will be search key. Oh, sorry. Search. Yeah, and we implementing our basic logic to for loop. For and n. Or if you get list, you passing just list.size or vector.size. And the main goal, you're creating for loop to iterate through the whole array. And on array, we need just check it, is it exist or not exist. If array I current element matches key, we returning not element, not key, but we are returning index because we need to get that index. Also, as you see, when we have function with return type, if we are returning on inside loop, we should still add default return as the last statement. And basically, there is two ways to make that. But now we leave normal iterative style in any language will be the same structure, just return -1. Why -1? Just any number which is explains for us that not founded, element not founded. And if not founded, you just returning -1. Because we finished our loop, iterate that whole array. When we saw here, when we finished our iterations, basically we not founded any element, we returning -1 or any magic number. If you're working with programming and you would like follow best practices, of course here it recommends use const, because we don't need copy whole array. And YC language, it's really great to start to work when you need to modify data, when you passing some non-modifiable data or mutable data, then also C Lion suggests that. And in C language, you're also able to feel that. Because when we passing here not const array reference, basically we copying the same array. If you have 100,000 elements inside array, or basically, or just, I don't know, just we say we have array size 1 megabyte. Maybe not possible to make that, but maybe it takes 1 megabyte at the moment. And if you take 1 megabyte for each array copy, basically when you call search function, you're passing another 1 megabyte, and you just, when you're writing const, you solving that problem and you sharing the same reference to your any place in code. In code, you're able to create some array, and you passing that reference from code. Like, I should create some array, like data set, for example. And we have fixed size data set, for example. 120, 22, 44, 99, 77, and so on. Maybe we should repeat the numbers. 22 twice, as you see. And here it shows sufflers for our index. It's really great stuff from C Lion now. Yeah. When you're creating the array here, in C language, when you're passing, or not only in C language, and any other language, when you're passing that variable, you're passing reference. Not reference, but copy, sorry. Copy of that parameter. And you're able to pass as const reference to that array if you need it. Or we're able, as I mentioned before, like able to pass references here instead of passing n as copy. Yeah, in C language you're able to make other type of passing parameters like as value, as reference, and so on. And here you're also able to create, instead of brackets, pointer. It will be as a also as an address. Like if you like array as an array, you're just passing as array, and it will be same. yeah, here's suggestions. Another suggestion which is from code conventions, do not use magic numbers. Because if you see -1, what the hell is here? I don't know. And how to fix that? You're able to just use extract, but if you don't have CLion, you didn't find that. There's a refactor constant, for example. I1, and you're able to say that our constant is not founded, or so. Okay, and as you see here, now modern days, it uses const keyword. It also added not so fast, and there is some keywords which is used as a constant before in C language was only define tag, and you're able to implement like define int p, not int, sorry, float. It was like this constants, but it's really bad practice at the moment when you're using define. And when the modern language come, like C++ 11's standard, it suggests to use const instead of define. Because define, it's in pre-compile. When compiler comes from the top, it takes that constant, and it's really invisible at the moment, and you're not able to get compile errors, for example. If you're writing some problems here, you get really messy code when you use define, for example. But if you're using C language, you still should use define for your const. And there is a lot of libraries used define. But for modern language, you should use static const int. And why it's better? Because now when we're reading, you will find that element not founded, and it explains what is a magic number here. And you don't need to know is -1 or 200 or so. It's not a big deal at the moment. And the main key, as you see here, if array key is equals that, we return that index. Pretty straightforward solution. And we able just use our linear search data set. As you see, we pass const int pointer. So instead of just array, you're able to use pointer also. It will be the same as array. Int n will be hardest part of array calculating stuff. We should calt or path any size, like int size. We passing data set. I forget how to size off. Sorry, size off. Because there is no other function. Best one is size off to determine size of array. Size off, divide by data set, the first element. Yeah, we're calculating size of current array because we don't know which number here. We're just passing size. And here we're also passing which element we would like to find it. We would like to find 22, for example. And you're able to say int result. And we will say like if result equals Element not founded, we're able to use constants. Or not equals. And you will print like element founded at pos. And you see result. And you will say, for example, value equals dataset result. If you would like to print value and you would like to print index, which position you will find. Else, element not founded. Element founded. We're just running. And it says element founded at pos 7 and val is 22. And here basically creating a single function for our solution. This solution of course works only with arrays. If you need to implement a solution, more flexible solution, at the moment I will not explain that, but STL library oriented to create templates. Able to create template to pass any type, for example, data structure if you need it, or any type list or so. And yeah, it really depends which type searching you would like to implement. Basically, you don't need to implement search for each different situation. You should maybe use templates, like from STL, or you just passing vector. If you know that using only vector, you don't need to use to implement linear search for other structures, for other data structures. And basically, easiest algorithm is like to iterate and check if it's key, return index. That's it. There is search. Straightforward, but it depends really on dataset size. Yeah. And of course, now we're searching only single element. How to implement to search multiple indexes? If we need it, because sometimes maybe we need to search all matches to return all matches. And we able just create separate function. I will add it because if we share code, linear search multiple results. And here is a really problem when we have the array. It really depends on. We're able to print inside here all matches, but it's not the best one solution. So it really depends on size of our array. So how to solve the problem? We're able to create copy of array, or just we're able to create array like temp or integer temp to hold indexes, and our temp size will be n, because if all results will match all sequence, there is possible that you will find all indexes will be matches. All elements inside the array will match our search. And for that case, we should get our main collection size and create temp array. Temp, it's really a great name, and you will know that here you're temporarily storing some info. Here we storing our match element indexes or so. And what's this writing? Okay. Now I'm continue, and you will see match elements indexes. Match elements indexes. That means we are storing those indexes if we match. And okay, we're not able to stop here when we returning I. So we need to redesign our algorithm a bit, because we need to create temp where it matches. Basically, we can't say here like this. Now instead of this, we should, if our match temp I, not sure which best approach to add those indexes, like we're able to print temp I will be the first if it Of course, if we will have some vector, we're able to insert, and we always to insert from start to end, and it will be much flexible structure. Now, when we have array, basically, if we say that if our match element is ninth, so if in temporary array we placing our at the 9th position our result. And it will be not the greatest solution because we need some counter or other stuff to count and to understand from which place we should, which size of results, or basically when we say that temp n, we're creating temp n, but we should, or we should do like this. Yeah, maybe there is too many options. I'm just using the naivest option just instead of adding much complexity. If temp I is equals our matched key, we just written that I. Else temp I equals -1. Or we create our also not magic number, extract constant. No. Okay, I'll create new one. You're able to use the same, but of course here it's not that. Element, no. Element key, not match. Something like that. We use the same -1, for example. Yeah, and now in our case, if we match, we give index. If not match, we gives -1s. So the reason why we need it, because we need the structure is much more clear, instead of just making some mess like adding from the start to our n size array and adding like founded indexes, and we don't know other indexes is okay or not okay, or just instead of testing we just say that -1 we not matching, and those which is matching we adding here. Of course, it's not optimized version, but for learning purpose, we just try to make some algorithm. Linear multiple search, multiple results. And now we try to implement that multiple results. And multiple results equals linear search. We give data set the same. We give size. We give key 22, for example. We do the same, but first case you return a single element. Another case will be multiple elements. And now the problem is we not returning, or we returning element not founded. So instead of this, we returning array. And here we should return our temp array. And now we see problem. Cast to int and then other stuff. Easiest way to here it's not allowed. I think that when you returning address of array, because it's multiple values, instead of brackets, which is allowed in different languages like in Java, you should use pointer. Like pointer basically is the same as array. Basically, when we remove those brackets and adding pointer, you will get the same results, because array by default it stores address to the first element. And here pretty much the same. Stack of memory. Yeah, here is maybe a problem because we're using stack memory. Here is not stack memory. We should basically to create in each place pointers and maybe allocate n elements, like if you using like this. If you say temp equals new, and basically it will be the same as the array, but you will fix problem, because if we are returning pointers, if we're working with addresses and we basically returning pointer type instead of stack, basically fixed size arrays is from stack, pointers is from heap when you allocating memory. And basically when you're allocating here new keyword, you're creating array, or dynamically creating array when you're working with pointer type. And then you will not face any warnings, because it will be the same type. Yeah, when you're working with C language, you must, or you should, to understand the basics for asterisks. And in some cases you need it basically when you're working with functions, because in functions you're able to pass reference and pointer type. Other languages also has, C# has also ref or so, and pointers has as a type. And other languages also use that techniques, and it helps for some situations. And now we try to test it if it works or not. We got array as a result, or pointer to array, or pointer to data. Doesn't matter, it's array, it's dynamically allocated data. We have basically same algorithm, but we, instead of returning -1 when we not matched, because when we not match, we just mark is not match, and if there is no matches, basically we not check that. We able to make some matching stuff, but we should create separate function for array match, because now we getting like result as array, and maybe we able to say that we not match here. For example, we use for loop. Maybe it helps. For we need to read our multiple results, and on the right, I'm not sure how to write. Multiple results, it's our array or list of items. On the left side, if we're using for each, we should use maybe auto it, and that help. Please fix it. Okay, maybe we should use for indexed loop. Later it will suggest we should move to the size of multiple results. Basically, multiple results will be the same as our collection we passed as a data set. Our data set here. And when we passing that, int I equals less than 0, we will work as normal array with multiple results from function return. We are returning array, or we get address for array, and you will just iterate through that results. And we able to pass our same logic, or we should create separate function if not result. You're able to create temp variable or just pass straightforward name multiple results I. If multiple results not founded, we printing our element. Else, now is a problem if we print like this, it will spam our window. We will see now. Okay, we will need new lines here first. And I need to edit other stuff. Multiple results. We printing some lines. Okay. Strange results because okay, the same. Here we should change it to our index, because we printing the same match from our function. It used single result. No, here also. Still missing something. Yeah, now it's okay. Now we got a result for multiple results. Basically, we iterating through the whole array, and if it not match, basically we should say element not match, and if it match it found it at position, 7th value is 22, and at position 11th value is 22. Basically, if you're changing if we're changing to all 22s or more, basically, we will iterate and show that element found at those locations. If we need to match multiple stuff. And of course, we're able to move out those functions outside here, just outside main, to add it more clear looking. For example, maybe we're able to use extract if it works. Let's try to make that refactor extract method, like const int data set in size foo, and we creating our below above. I know which below or above. Oh, sorry. Refactor extract method. We just above, and we creating here is multiple results. Multiple matches testing, just some function. And as you see here, we got our function created, multiple matches testing, parameters for our data set, and size. Basically, we reduce our boilerplate, and we basically able to always to make like this. We write our logic, and later we test. Because our data set is important, and later we need size, we just able to extract also and that one. Refactor, extract, and we create our linear single match testing, because we should follow the same pattern of namings. Okay. Yeah, or just above. We created single match testing extract for main and multiple match. And instead of just when I'm wasting time to just looking to more lines here, I'm able to just comment here. And it's easier to read it later. And basically here it's how to find that info. And when you implement that, you're able to fix it also problems inside functions later. And if you face some problems, you will straightforward move to that function and try to solve that problem. Now, if I would like to show only match elements, and if I would like to say that my keyword is not matched, like the reason why we need at all those element not found or key not found and so on, because we should say sometime when we found it, when we not found it anything. If I enter, for example, search key here. Yep, we should extract also in key. Key int key. And here also we should pass key, int key, because we need pass from outside for function. Yeah, and for example we say 1. For example, we say 1. When you're printing, we will get some result like element not found, not found, not found, single match. Also there is a difference between those. For single case it's fine, you will inform that. For other case, like when we have multiple matches, else statement not working. And we should think how to make that work, to inform that. If we doesn't have any function which is checks is it exists or not exists in multiple result set, like in our array there is no any matches, we can't get a result from here, because we just filling out our array and we filling out with return, we are returning filled array, like our temp array. And if we filled our array, basically we not able to get that. Doesn't matter, we returning array in any case, like is it any matches or not any matches. And of course you're able to fix it, implement functionality inside here, but it will be not a greatest solution, because then you need better to create some separate function for it. Because if we implementing too much inside the same place, we just, if we filling and we trying to multiple results storing somewhere, and then we should create separate function which is checks by given array if it's true or not true or something like that. Or just write the code inside straightforward to our implementation when we calling function, because we are returning a result. If we would like not to implement function, separate function, or we able to implement function later when we implemented that element not found it, because I don't want to repeat that many times. I'm able to say break, but I can't say break because we should iterate through the whole collection. And here there is of course functions which is find all elements inside, like by some -1, for example. If all elements is -1, that means it doesn't have any results. And here of course also there is plenty of solutions how to think and implement that check for our case, to determine that element not founded, or your results not founded, something like that. Okay, now we're able to count how many elements inside data set is -1. Or maybe there is other solution, but we will just count if we want. For example, we create int count, we say 0, count plus plus. We just counting how many elements inside here is -1, or not founded element. And when we say like this, we should say if we not founded any match. Well, now we doesn't have any. If we have vector map or so, we're able to check straightforward using functions. But when we don't have, we should implement ourselves that functionality. If we're using counter, we just counting how many -1 added to our collection. Okay, what is the reason? What is the point to count that? Yeah, if we count those, we able to compare with the size of our array and say like else counting, and later after this, yeah, maybe we create separate function, not inside the loop, because we don't need to go inside the loop. There is no reason to loop itself the same stuff or check inside the loop, because if we place the if statement inside the loop, you repeat the same if and check, wasting some extra checks for just simple problem. For counting, you just plus one, plus one, plus one, plus one, and so on. And if count is equals size, you just print some element not founded, or just printing results not found, or not found any matches. I forget how to, not found it any, maybe search results 404 not found any results, or just some message, different message. To see it will be different. Basically, we check if count equals size, because we counting, we getting -1, and when we got all elements is -1, then we say that, of course, able to optimize that else also. If you find any matches, you able just stop counting, for example. If you would like to reduce count plus plus, because here you each time when you find -1, you counting plus plus. But basically, of course, for else if it's not really clear or correct stuff, but able to write like if no, it's not working like this. Okay, forget about that. Yeah, but able to use optimized version for counter, because we counting each time for, doesn't matter is it any matches inside or not. And if you would like to reduce, we should just, if we found single match, then we should just stop count, because our count, or just when we else, yeah, I'm able to make that, but I'm not maybe adding that at the moment. Yeah, if count size is equal size, that means there is no results. And for single match, basically you don't need to fix or create some other function. For multiple matches, oh, there is no new lines. Basically, there is other solutions, but that one is one solution of multiple solutions. Like search results 404 not found at any results. If you passing some 22, you will get matches. From that case, and yeah, if you place here 22, you will find and get that index. Basically, here is only single linear search, a basic approach, but I will already show that different stuff like const when you need to use it, and maybe you have different results to find that. And also you're able to transform to pass vector, and maybe we don't have a lot of time. I don't want to start the binary search. Maybe I will show next lecture or next time, because it's a bit longer solution. But binary search, if we're talking to like this, it oriented, I will show that here. Basically, you should sort or implement sorting algorithm first to sort array, and when it's sorted, basically you're dividing by two parts, left and right, left and right, left and right, and you're moving like from the full array, you divide it to the middle and picking left or right side. If you move to right side, you take caring only the right side. And later you go also find the middle element, right side, left or right. If left, basically you're picking the left, like two elements only. And the last result will be the middle element, like the final match. But we will discuss later with that binary search. And it's really effective algorithm when you need to find fast something, but you need to have sorted array. If your collection is not sorted, so maybe sometimes binary search not the best case when you need to use it, because you should sort. If you're not sorting, you not get results. For a straightforward solution, you don't need to sort. You're just looking, but of course you're wasting time when you iterating those through that collection. But if you have small sets, it faster will work linear search. But yeah, it really depends on your problem solving. And what else we can add it to that? Yeah, you're also able to extract functions like those functions, another. And we able to add another function for vector. When you have like a search like this, it really depends. If you have objects like classes, maybe you need in that class to find something which is age, for example, or so. We implement separate function for integer, checks for char, for other, and so on, or just be able to implement inside that class. It also really depends on your needs. Yeah, when we see here, to switch to vector, maybe I will add with vector when we use some collection. STL container vector. Linear search using vector. And what is the difference? Basically, it's nothing different, because algorithm working the same. Doesn't matter which type of collection, because it's linear data structure also. You're able to pass vector. And here it depends which type you would like info. And a list, maybe. No. Vector data, for example. Yeah, it's also suggested, as you see, yellow. Oh, it's okay. If there is some suggestions from IDE, you should use it if it's okay when you're looking. When you're passing vector data, basically you're able to remove n. Data is, oh, it's shown now. Const ref. As you see, you should use const reference because you don't need to copy whole collection as array before. And it's really strange, like when you need ampersand, const, but it makes it not unmodifiable, and it makes a reference to that vector which you pass from outside. Key also should stay here, and instead here you just call data.size because here is class. And basically we changed our implementation using vector. When you look vector to array, it's small difference between that, but you don't need extra parameter to calc your size of collection. And STL library also has array, which is not fixed size, but it's more dynamic or more dynamic stuff. From STL library, able to find array also. Different array, not the same array, but it's also calls array. And when you're searching, basically, I don't know what able to that. We should implement our function here. Single match using vector. Okay, maybe I later will add that fix. I will should add to do. I will add code and place to your course. To do vector display to console. Okay.